What is selective thermolysis? Let us look at this graph to understand. The vertical line represents the temperature of the cells. The horizontal line represents the time scale. We use a pulsing mode and not continuous. T on is the time the laser is activated. T off is the time the laser is switched off. When the laser is switched on, the cell temperature increases. If the cell does not reach the point of destruction when the laser is switched off, then it cools down. Why is it important? Why not just use continuous wave and heat the cell to the point of vaporization? The first factor to understand is that different sizes and types of tissue will cool down at different speeds. Bigger structures will be slower at cooling down than small structures, for example. Of course, other parameters can increase the cell temperature, such as increasing the power output of the laser. Another example is the spot size. For the same power, if you decrease the spot size, then the same energy is focused on a smaller area and increases the temperature faster. The second factor to understand is the pulse train. Imagine not one pulse but a serial of them. In this first case, when the T off is long, then the cell has time to cool down before the next pulse and no cells are destroyed. In this second case, when T off is short, then the cell has no time to cool down entirely before the next pulse. There is still remaining heat. As a result, the temperature of the cell rises higher in the second pulse than with the first pulse. Now if you look at two different tissues which cool down at different speeds. In the first case, when T off is long, both tissues are cooling off entirely in between each pulse. No tissues are destroyed. In the second case, when T off is short, only one tissue cools down in between pulses, whereas the other is building heat. The tissue accumulates heat until the point of destruction, whereas the other tissues remain healthy. This is how it is possible to heat and destroy selectively specific tissues such as hair follicles and potentially cells infected with toe fungus without overheating the surrounding tissue.